So compound interest is a little bit different in the idea that we are going to be reinvesting our interest or our profits. So let's take a look at a comparison. So for simple interest, let's start with a present value of $100. And let's start with a yearly interest rate of 3%, and let's have our time equal 1 year. So if that's the case, then using simple interest, we would have that our future value would be 100 times 1 plus r, so 0.03 times 1, which would give us 100 times 1.03, which would be $103. So after 1 year, we would have had an account balance of $103. So let's compound the interest twice per year. Okay, so if we're going to do that, we're going to use our formula for future value. So our future value is going to be our present value times 1 plus I times n, and we need to change our things. So if we're doing it twice per year, we're going to have 2 periods. So our n is going to be 2, and our I is going to be our interest rate divided by the number of periods, so 0.03 divided by 2, so 0.015. So using our simple interest formula, we could then calculate our future value after 1 period. So our future value would be our present value of $100 times 1 plus our I, which is 0.015, times our period, which is going to be 1 in this case, because we're doing it for 6 months. So that gives us 100 times 1.015, which gives us $101.50. And at 6 months, that would make sense, because in 1 year, we made $3, and in 6 months, how much did we make? $1.50. That seems reasonable. So now we want to calculate for the next 6 months. So our future value is equal to our present value, which is $101.50 times 1 plus 0.015 times 1. So we get 101.50 times 1.015, and we put that into our calculator. So 101.5 times 1.015, and we get 103.02. So when we compounded our interest twice, we'll notice we now have a different answer. So the difference between the simple interest and the compound interest is that 2 cents is the interest that you earned for the second half of the year on the $3 in interest you earned in the first half of the year. So compound interest charges you interest on your interest. So something we could do, we could play some math games here to see how this is. So we had our term right here of 101.50, but that was equal to this, which is the same as this. So if I replace that with what it's the same as, 100 times 1.015 times this piece right here, when we simplified it, it turned into the same thing, 1.015. And in fact, now we have two factors. So this would simplify to 100 times 1.015 squared. And if you kept doing this, you would find that you would get, if you did it 3 times, you would get the same thing to the 3rd power and so forth. So combining all of this in general, we get the following formula for compound interest. We get that the future value is equal to the present value times one plus I raised to the n. Using that, let's go ahead and take a look at example number 1. So, for example, we want to find the future value of an investment earning 0.5% interest per month for 36 months. So our future value is going to be equal to our present value times 1 plus 0.5. Oops, I need some more zeros. So I've got to turn my percent into a decimal. So 0.005 raised to the 36th. So that's going to be our present value times 1 plus 1.005 raised to the 36th power. So if we go 1.005, we raise that to the 36th power, we get 1.1967 for our solution. So our future value would be 1.1967 times our present value. And if we took that number and we divide it by 36, we'll notice that would give us our equivalent, our annualized interest rate per month, which would be 0.03, or about 3.3%. But if you take the interest rate that we had, 0.5, and if you times that by 12 months, we get that the interest rate we were compounding was 6. So let's take a look at our next example. So find the future value of an investment earning 6% interest per year with the interest invested every month for 3 years. So, first thing we would want to do to use our formula is this time we'll notice it's pretty much the same idea that we had here, but what is our compounding period still? We're compounding everything per month. So we can use that our compounding formula I is equal to our annual interest rate and M, or N, is the number of times compounded. And the key thing is with this, it is once again per year. It's our annual interest rate, and we're going to have T equal to time. So putting those together, our future value in this form is our present value times 1 plus R divided by M raised to the MT. So our this was what's taking the place of I in our formula. Our I is R divided by M. That we're seeing right here. So using our same thing, our future value is equal to our present value times 1 plus 0.06 divided by, for compounding it monthly, divided by 12 raised to the 12 times 3. So if we put all of this into our calculator, we have 1 plus 0.06 divided by 12, and we raise that to the 12 times 3. And we hit enter, and we'll notice we get the same value we got in the previous problem, right? Because it's really just two different ways to do the same thing once again. So one of the formulas with the R and the M and the T is doing everything in terms of annual rates, whereas the first formula that we were using I and N, I is the interest rate per period, and N is the number of periods that we're using. So two formulas that have the same net effect, but we have to be careful with our units when we're working with these problems. So let's revisit an example that we did in the previous section. So once again, your child is going to need $3,000 to study abroad in 2 years. How much money would need to be invested now at 4% compounded monthly to have enough money for the trip. So remember, our future value is equal to our present value times 1 plus I raised to the n. So we were given 4% compounded monthly and 2 years. So we take our interest rate, so our R is 4% or 0.04, and we divide it by 12. So we'll get that. And they're going to study abroad for 2 years, so that's 2 times 12 is 24. So we want the future value to be 3,000. So if we solve by dividing both sides of this equation by 1 plus I raised to the n, the present value, or the money I would need now to have a future value, FV, would be parentheses 1 plus I to the n. So our future value is going to be 3,000 divided by 1 plus 0.04 over 12, and we're going to raise that to the 24th power.
Professor?
So now we can put all this into our formula. So we go 3,000 divided by, and we're going to go parenthesis 1 plus another fraction 0.03 over 4, or over 12, raised to the 24. We hit enter, and this time we get 2825.51. So let's compare the previous problem, which we were just doing, with the example from 3.1. We noticed both problems had an interest rate of 4% per year, but the amounts were different. So we want to talk about a nominal interest rate versus the effective interest rate. So the effective interest rate, so R sub EFF, is equal to 1 plus the nominal interest rate divided by m raised to the m minus 1. So that gives us a way to calculate the effective interest rate of compound interest in terms of what it would be in a simplified simple interest form. So if you've ever gotten a mortgage, you'll notice that they quote you 2 rates. They'll tell you what your rate is, and then they will tell you what your effective rate is. And this is how they're doing it, because interest is often compounded, and so you actually end up paying a higher interest rate than you would think. All right. Let's go ahead and do the computation. So our R effective would be from our previous problem. So we have 2 years compounded monthly for 4 years. So we're going to have 1 plus our 4%, so 0.04, and if we calculate this, we have 1 plus 0.04 over 12. And we would get the effective interest rate. I'll take away 1. Is going to be closer to 4.1%, so 4.07. So in this case, it would be about 4.1% after rounding. Alright, looks like we've got time for next example, and then we're going to go ahead and we'll be out of time for today. So Yumiko deposits $10,000 in a 529 college saving plan. The plan pays 3% interest compounded quarterly. Find a function for the account balance. Use the function to find the account balance after 4, 8, 12, and 20 years, and find the time it will take for the account balance to be $22,500. So our present value is going to be 10,000, and the plan pays 3% interest per year compounded quarterly. So our I is going to be 0.03. So our interest is going to be 0.03, and then it's compounded quarterly. So there are 4 quarters in a year, so we will divide by 4. And then we want to use this to find the account balance after 4, 8, 12, and 20 years. So in this case, we're probably not going to want to use the formula I equals 0.03 over 4 and n equals the number of periods times years, because that's going to complicate our math. So let's use our future value formula is going to be PV times 1 plus R divided by M raised to the MT. So in that case, if we're compounding quarterly, our M is going to be compounding quarterly, so that's going to be 4. Our interest rate is going to be 3%, and then we can use the time in years. If we use the other formula, we'd have to do conversions forward and backward, and that would make our life a little bit more difficult. So our future value is going to be 10,000 times 1 plus 0.03 divided by the number of times we're compounding, which is 4, raised to the 4 times t. So we can then use this to calculate a whole bunch of these values. So our calculator will be very helpful for this. So let's grab our y equals. We put in our 10,000, and we go 1 plus 0.03 divided by 4, and then we raise that to the 4x. And we have to use x's because our calculator only understands x's. So then if we want to calculate the account balance at 4, 8, 12, and 20 years, one way is to just go second graph and make a table. So after 4 years, we'd have $10,000, $10,938. And this is helpful, but our calculator won't give us down to the cent. There's just not enough width in the column. So we could then calculate those in a different way by using the input notation on our calculator. So one way to get these values is from a table.
Can you show how you got that table again one more time?
So,
like, can you go back to the Y1 that you put in?
yeah, you just go second and press graph.
Yeah, but can you go to your Y1? Because I typed in the same thing you did and I did not get.
So 10,000 times 1.03 divided by 4 raised to the 4x.
Okay. Yeah, I did that. And it's pulling up like a bunch of decimals and negative x's.
So
And
you
then,
mean like your table, your x's are negative. So just
okay,
press your
yours
plus
is
key.
starting at 0. I don't know why. Mine didn't.
So just to fix that, go second and window to open your table set menu. So second window, open your table set menu, and just choose to start your table at 0.
Oh. Okay, thank you.
That fix it?
Yeah.
Sweet. Okay. So we've got that, and we can scroll up and down in our table. The next thing we could do is if we wanted specific values, we press alpha and trace, we choose y1, and if we say y1 of 4, we'll notice, okay, if I look at 4, my table had 11,270. Well, my calculator, when I do it this way, gives me a bit more accuracy. I get 11,269 and 92 cents. All right, so in that, it's rounding everything to the nearest whole number. So we could do that to calculate the values that it asked. So there's 4, 8, 12. I'll skip a couple and go all the way to 20. And we get these values. So getting those, we could answer the question. The last one that is asked is, well, how long does it take for the account balance to become 22,500? So we want to know, well, when does FV equal 22,500? Well, that would give us 22,500 is equal to 10,000 times 1 plus 0.03 over 4 raised to the 4t. And we now need to solve that equation for t. So we'll recognize that this is an exponential equation. And to resolve exponential equations, at some point we're going to need to use a logarithm. So the first thing we need to do is isolate our exponential. So we're going to divide by 10,000, and we're going to divide by 10,000. That gives us 22,500 divided by 10,000 is equal to 1 plus 0.03 over 4 raised to the 4t. So now to undo that exponential, or to get it out, we're going to need to take a logarithm of both sides of this equation. So there are a couple of different ways that we can do this. So we can take a logarithm of both sides, but the base of the logarithm, if it matches what the base of the exponential is, they're going to cancel out. So we'll make our base 1 plus 0.03 over 4. And if that's the case, this logarithm and this base will reduce out, and we're left with the logarithm of 1 plus 0.03 over 4 of that whole thing, 22500, all over 10,000 is equal to 4t, and then we divide by 4, and that's going to give us our answer. So now how do I put that into my calculator? So let's start with our logarithm. To get our logarithm where we can change the base, we press alpha in window, and we'll notice that it is choice number 5 on our graphing device. So now I'm down here, I'm going to put in 1 plus 0.03 divided by 4. And then in here, I will do 22,500. and divide that by 10,000. It's only 1,000, I need another 0. I hit enter, I get this amount, and then all of that divided by 4 gives me the following value. So then if that's the case, it seems it's going to take, according to this, about 27 years.